Okay, so problem 8.29. Sketch the graph of the function f equals x plus the logarithm of the absolute value of x squared minus 1. Okay, let's do that one. So the first part is f is x plus the logarithm of x squared minus 1. Okay, so the first thing is to get the domain of this thing. Okay, the domain of x is obviously the real line, but the domain of the logarithm is the positive numbers, right? Now we have an absolute value thing here, so this is going to be non-negative, right? So the domain of f is going to be every point except the points that make this equal to 0, and so that's going to be exactly, there are only two roots of this, 1 and minus 1, right? Minus 1 and 1. So at this point we will have an asymptote, a vertical asymptote, right? Because that's what the logarithm has at that point, right? So we can actually get what happens when you go to this minus 1 asymptote on the left. So then you have minus 1 and then plus the logarithm, so this is minus 1 squared minus 1, so this is going to minus infinity, right? Plus x, so this is going to be minus infinity, right? And actually you can do for every asymptote, this is also the same as the limit when x goes to minus 1 on the right, sorry, this is going to be minus infinity as well, because this is going to be close to 0, and also for the other asymptote 1. Okay. Okay. Now we have that, so we have, let's keep start sketching this. We have minus 1 and 1, right? And the function is going to be like this, and then like this, right? Okay, now, when is this function, where is the roots, where are the roots of this function? Where does this cross the x-axis? Well, when this is equal to 0, right? So f of x equals to 0, it's when x plus the logarithm of the square root of x minus 1 equals 0, right? And let's see, so there's going to be or in other words, the logarithm of the square root of x, absolute value of x squared minus 1 is equal to minus x. And so it's not easy to see many roots here, but obviously x equals 0 is going to be a root, right? Because this is the logarithm of 1, 0 equals 0 is a root. So at 0 we have this. And then let's see, so we can get the limit when x goes to plus infinity of f, and this is going to infinity, this is going to infinity, this is going to be plus infinity, so there has to be a root here at some point in the positive axis, right? And also the limit when x goes to minus infinity of f is going to be, this is going to be minus infinity, and this goes to plus infinity, but this is negligible when compared to this, so we have minus infinity, so this is going to be like this, and this is going to go like that, right? And so we can see, if this doesn't, this maybe crosses the x-axis, maybe it doesn't. This has to cross the x-axis here, and this has to cross the x-axis at some point, right? Now let's compute the extrema, right? So this function is differentiable everywhere in its domain. Okay, so f prime is 1, and then the derivative of the logarithm is 2x divided by x squared minus 1. And if you're wondering about the signs because of the absolute value, you think about when x squared minus 1 is greater than 0, right? Then we have the absolute value of x squared minus 1, so the derivative of that is going to be x squared minus 1, 2x. And then if x squared minus 1 is smaller than 0, then the absolute value of this is 1 minus the x squared, so then we have 1 minus x squared, and the derivative of this is minus 2x, and you can see that this is exactly the same as this, okay? So the derivative of the logarithm of the absolute value of something is just the argument of the logarithm and times the derivative of the argument. Okay, so this is the derivative. This is exactly the same as x squared plus 2x plus 2x plus 1. Is correct? No, sorry, minus 1. Yes, minus 1. And then this is x squared minus 1. And there, if we equate this to 0, we have two roots of this. x1 is minus 1 minus the square root of 2. x2 is minus 1 plus the square root of 2. So one of this is going to be around here. And minus 1 plus the square root of 2 is a positive number, but close to 0. It's smaller than 1, so maybe something like here, right? Now, if you evaluate the function in these points, you get minus 1 minus the square root of 2, and then this is 1 plus the square root of 2 squared, which is 1 plus 2 plus 2 square root of 2, right? And then minus 1, which is the argument here, minus 1, so you get 2 times 1 plus the square root of 2, sorry. And so you have to compare this with, so this is the logarithm of 2 plus 2 times the square root of 2, and this is going to be smaller than minus 1 plus the square root of 2. So this is going to be a negative number. Okay, you compare that. So the you can see here that we actually need a maximum. You don't need to, it's a maximum that's negative, right? You don't need to compute the second derivative because you can actually compute this really well, right? You can see here that's going to do something like this. But yeah, maybe you can compute the second derivative to see that this is actually concave, right? And now here, if you compute the value of the function, here you have the square root of 2 minus 1 plus something that's positive as well, so you have a positive number, maybe something here. And so you see, right, because you need to cross the x-axis here at 0. Wait a minute. You have this value here, and then the maximum. So you don't need to really check that these two things are maximums, because you can see from the picture. I'm really bad at plotting, sorry. So this is this, and then you have this, right? That's the more or less the function, right? So yes, you could actually, you know, compute the second derivative here of this function, and then get that the function is actually, it's going to be concave everywhere. So that's how we're plotting this. And if you want to see how the function looks like, actually, wait a minute. Whoop, what's the problem? Okay, yes, here. So this is more like this. Okay, you get this maximum around here, and it goes down. This goes up. You get a maximum here, down. So these are the asymptotes, and you get up to infinity. Okay. Now, the second part is based on the previous graph. Plot these functions g, and let me have this here. Okay, g and h. Okay, which are basically the second part is g is the absolute value of x plus the logarithm of x squared minus 1. And if you see, you can write this like the absolute value of x squared. So g is just the f of the absolute value, right? And of x. So that means that f is g is symmetric, right? Because g of minus x is going to be f of the absolute value of minus x, which is exactly the same as the f of the absolute value of x, which is exactly the same as g of x. So that means that g is an even function. And what that means is that the function is going to be have in the negative x-axis, it's going to have the same form as it has in the positive side, but mirrored. And this is what I'm plotting here, right? You can see this is a mirrored image. This is the positive side of f, and it's mirrored backward. Okay. And then lastly, we have h, which is the absolute value of f, right? And that means means that, you know, for every part that's negative, you just need to how to say this? This is to mirror here that, right? So you have something like this, right? And then this goes like this, and then like this, right? And then like this. Okay, so everything that's negative, you mirror it up on the positive side. So that's what you get here. You get this. These are the asymptotes. Okay. So this goes to plus infinity and plus infinity. Okay.